In today's lesson, you're going to learn how to write and graph compound inequalities. So let's take a look at what a compound inequality is. It's an inequality formed by joining two inequalities with the word and or the word or. On the ones on the left, the graph of a compound inequality with the word and is the intersection of the graphs of the inequalities. The graph shows number that are solutions of both. So you see x is greater than or equal to 2, and it's graphed at the right, and x is less than 5. And the points where they intersect or overlap is the part that you would see graphed in the compound inequality. So when x is greater than or equal to 2 and less than 5, this is how you write that inequality, okay, that compound inequality. It's joining them both, and it means and. On the right-hand side, the graph of an inequality with or is the union of the graphs of the inequalities. The graph shows number that are solutions of either inequality. So y is less than or equal to -2, or y is greater than 1. Notice that the graphs do not overlap, and therefore they're going in opposite directions. So let's write the sentence as an inequality. Graph the inequality. In the first one, it says a number d is more than 0 and less than 10. So you have a couple things going on here. Okay? You have d is more than 0 and d is less than 10. Now if you recall, this will show on the graph, so we could do the graph, but it also shows it's going to be an overlap. It's going to be an and compound inequality, and we'll put the letter D in the middle. So start with the least number. Always do smallest to largest. So 0 is less than D, which is less than 10. And then the graph of that would show, I'm just going to count by 5s here. And I'll change the color so you can see the graph a little bit better. So we have an open circle at 0, and we have an open circle at 10, and the numbers in between are graphed as the compound inequality. 0 is less than D, which is less than 10, because D is greater than 0 and D is less than 10. For the second one, you can see that a number A is fewer than -6 or no less than -3. So we can see A is less than -6, and then we have to recall what no less than -3 means. So it could be -3, it could be -2, 1, it could be greater than. All the numbers -3. So greater than or equal to the -3. So in this case, when we graph it, we could graph all the numbers that are less than -6, so an open circle at -6 and the arrow goes left, and all the numbers that are greater than or equal to -3, so a closed circle at -3, and it goes right. So this is an or compound inequality. So to solve a compound inequality, you want to basically look at each side. So this reading left to right says 5 is less than or equal to m plus 4, which is less than 10. So we have two things to solve here. We have 5 is less than m plus 4, and m plus 4 is less than 10. So we'll subtract 4. So we'll get 1 is less than or equal to m. Solve this one by subtracting 4 and get m is less than 6. So our compound inequality is 1 is less than or equal to m, which is less than 6, and then we can graph it. So we would have a closed circle at 1 and m is greater than 1, and an open circle at 6 and all the numbers between 1 and 6. Right? For the second part, you have an or compound inequality. So we'll solve basically each side of these separately. So we'll subtract 3. So 4c is going to be less than or equal to negative 8. Divide by 4 and get c is less than or equal to negative 2. Or solve this one and add 8 and get c is greater than 7. So c is less than or equal to negative 2, or c is greater than 7. So a closed circle at negative 2 pointing left, and an open circle at 7 pointing right. We'll watch this short video.
How do you solve compound inequalities? For example, how do you know what values of x satisfy the following inequality? Negative 2x plus 7 is less than 5x, or 4x is less than negative 12. In this lesson, you will learn how to solve compound inequalities by using additive and multiplicative inverses. First, let's review. So if we have this inequality, 3x is greater than 2x plus 7. In order to solve this, we need to have one side be x's and one side be numbers. So we need to, first of all, subtract 2x from both sides, because 2x and negative 2x are additive inverses of each other. Then once we do this, we have x is greater than 7. Since there's no coefficient on the x, there's no need to use any multiplicative inverses here. We can check our work here. We can pick a number that satisfies the ending or the answer inequality, like 9. because 9 is greater than 7, and then we can check to see if it satisfies our original one. 3 times 9 is greater than 2 times 9 plus 7. That is a true statement, so we know our solution here is correct. The word or, when it comes to inequalities, means that x must satisfy one of those inequalities. If you have the word and, it means that x must satisfy both of the inequalities. Let's start with one that involves the word or. Negative 2x plus 7 is less than 5x, or 4x is less than negative 12. So what we have here are two inequalities, but they're essentially one question. So what we can do is we can solve both inequalities, get our two solutions, and then we know whatever number we choose, in order for it to be a solution, it has to satisfy one of those inequalities. So we can solve these separately first. So let's start with the left side one. So we need to add 2x to both sides here, and then we will be left with 7 is less than 7x. Now we need to multiply by 1/7 because that's the multiplicative inverse of 7. So once we do that, we have 1 is less than x. Now we need to solve our right side inequality. We need to multiply by 1/4 because 4 and 1/4 are multiplicative inverses. Once we do that, we have x is less than negative 3. Remember here that since we multiplied by positive numbers, we keep the inequality sign in the same direction. So here our solution to this inequality is 1 is less than x, or x is less than negative 3. So we know that any number that we choose for x must satisfy one of these. So let's check this. Let's choose x equals 2. We know that it satisfies the left-hand side one because 1 is less than 2. So now we need to check to see if it satisfies the original inequality whose answer was 1 is less than x. So then we have negative 2 times 2 plus 7 is less than 5 times 2. That is a true statement, so we know that our solution here is correct. Now let's try one that has the word and. 5a plus 2 is less than 7, and 6a is greater than negative 12. When we get our solutions here, we know that in order for a number to satisfy it, it must satisfy both of these inequalities, not just one. That's what the word and means. So let's solve the one on the left here. We need to subtract 2 from both sides. Then we have 5a is less than 5. Multiply by 1/5 because it's the multiplicative inverse. And then we have a is less than 1. Then to solve the right-hand side one, multiply by 1/6. And then we have a is greater than negative 2. So our solution here is a is less than 1 and a is greater than 2. So we know that any number that we choose for a must satisfy both of those. So let's check this. If we say that a is equal to 0, well 0 is bigger than negative 2, so it satisfies that one. And 0 is less than 1, so it satisfies that one. Now let's check it in the two original ones. 5 times 0 plus 2 is less than 7, and 6 times 0 is greater than negative 12. A common mistake here is interpreting the inequality wrong. Remember that or means that x must satisfy one inequality, and x must satisfy both inequalities. In this lesson, you have learned how to solve compound inequalities by using additive and multiplicative inverses.